Hello everyone. Today we are going to do the section 2.3. It's about families of functions and transformations and symmetry, but today we're going to focus only on transformations. In this section our goal is to see how similar graphs are related to each other. So for that we let a, h and k are real numbers with a to be a non-zero number, and this function y equals a times f of x minus h plus k. This equation is a transformation of the function y equals fx. So here this y equals fx function, we call that is to be our parent function, and we using this a, h and k, these values, we change this parent function into something like this: a times f of x minus h plus k. Maybe not all these changes, but some of them. So this is called a transformation to the function y equals fx. So there are different types of transformations. The first transformation that we're going to do is called the horizontal transformation. In horizontal transformation is related to this h value here. We take h to be a positive number greater than 0, and then if you look at this function y equals f of x minus h. So here also the parent function, original one is y equals fx function, and with using this h value we change that function to be f of x minus h. It's like we are changing the argument that we are plugging x minus h. Now this is called a transformation of h units to the right of the graph, this one, original one. So it's like we are moving the graph of this original graph to the right hand side by h units. You can see that in this example. So we are taking fx to be the square root of x function. In this function, if you draw the graph, it looks like this. So this is the parent graph. So now let's consider this one, the new function called gx, which is the square root of x minus 3. Here this 3 is the h value that we used before, x minus h, and here it is x minus 3, so it is h is 3 here. So that means we should move this graph, the green one, to the right hand side because it's x minus 3. So we should move this graph to the right hand side by 3 units. So when you move that, it looks like this. So it's starting at 3 and keep going. So it's 3 units to the right. This is the horizontal transformation to the right. Now the other case is this one. The graph of y equals f of x plus h. Instead of x minus h, here we have x plus h. So this is the transformation of h units to the left of the graph of this one, original. Now let's look at the same example. Here we have fx equals square root of x, the same graph, the parent graph. Now we are taking x plus 5. That is our hx function. You can see that in here, now this graph has been moved by 5 units to the left hand side because it's x plus 5 here. Plus 5 means it should move to the left hand side by 5 units. So that is the horizontal left hand side transformation. So the next type is called the reflection. Let's say we have a function y equals minus of f of x. The parent graph is y equals f of x. So here now we are changing it and we are multiplying it by -1. Then it becomes y equals minus of f of x. So this is called a reflection transformation. So that means the graph is changing across the fx axis. You can see that here we have fx equals x squared function, which is the parabolic function that we discussed before. In this function, if we multiply this equation by minus sign or minus 1, and let's take that is to be the ex function, so that means it is completely upside down. So this is the fx equals minus x squared function. You can see that it's been reflected around the x-axis. Now let's look at the same example, another example in the same transformation type. Here we have fx equals x to the power 3 function. It is this function. This is one of our basic functions we discussed before. And now I'm multiplying it by minus 1 or minus sign, so that becomes minus of x to the power 3. And let's take that is to be gx function. So now it should be reflected about the x-axis. So now it looks like this. So this is a reflection transformation. The third type is called the stretching and shrinking. So that is when we change a function into this form. Let's take y to be a times of fx. Here I'm taking my a to be only a positive number, and this is the parent y equals fx function. It's like we are multiplying this fx function by a. That's what we are doing here. There are two cases in this stretching and shrinking. The first case is stretching, the second one is shrinking. Stretching is when we multiply this equation by a number greater than 1. So that means this a that we are multiplying is bigger than 1. And the shrinking case is when a is in between 0 and 1. We know that should be positive, and when it is less than 1, it is called a shrinking transformation. So now let's look at these two cases. Here again I'm taking my fx to be square root of x. We know the graph, and this is the parent one. We know that if we plug in 1 here, we can get 1 in the y-axis. So this is the shape of the graph. So now let's look at this case. The new gx, this function gx, it's defined to be 2 times of square root of x. This 2 is the one that we are doing this stretching here. So a equals 2k. So it is bigger than 1, so it is a stretching transformation. So you can see that this graph is a little above this original size. So it's exactly, if you plug in 1 to this function, now it is not 1, it should be 2, because we are multiplying by it 2. So it is kind of stretching. The other case is we are multiplying the same equation by 1/2. So this is a equals 1/2 case. So it is less than 1, so this is a shrinking transformation. You can see that the graph is being shrinking. So here when you plug in 1, it is 1/2 now. 1, you get y value, you get 1/2 as the y value here. So this is a shrinking transformation. Let's move to the last one. Vertical transformation. If you take a positive number k and consider this equation, again the parent one is y equals fx, and now we are taking fx plus k. So you can see that this k is, we are adding this k is completely outside of this equation. We are not adding it directly to this argument x. It's not, we are not adding that, adding k to this x. Instead we are adding it outside. So what is happening here? If k is positive, we say that we move this graph upward by k units. And when we are adding here. So for an example, you can see that the same square root of x function, and this gx function is we are adding 3 units, not to this argument x, not to the variable x, but outside separately 3 units. So that means we should move this original graph to the upward by 3 units. So now it is looks like this. The other case is that let's take k to be let's take k to be positive number, and now consider fx minus k. The last case, this one was fx plus k. Here I'm taking fx minus k. So that means we should move the graph to the downward by k units. So that means If you look at this new function fx equals x squared, the parabolic function. Now, and this new function gx x squared minus 3. So here k is 3 but it's minus 3 now. So that means we should move this graph downward by 3 units. You know that here it is 0 0 where it's crossing, and since we moved it by 3 units downward, now it is negative 3 and 0. So it is ends up at negative 3. So it's 3 units downward transformation. Okay, those are the all transformations that we have. But let's look at multiple transformations. So here we're going to consider all the transformations together in a one function. So if you look at this graph or this function y equals a times f of x minus h plus k, here a represents the stretching or shrinking, and k, you know that is a horizontal transformation, and k is the vertical transformation. And we have to preserve this order. We have to understand these all transformations in this order. If you want to make this graph with the given fx function, first you need to do the horizontal transformation, and then do reflection, stretching and shrinking transformations, that is with a. And the third one is finally you do the vertical transformation, that means this k. So let's look at this example. Here I have given this equation, y equals negative 2 times x minus 3 to the power 2 plus 4, this equation. Here you can see that here we have multiple transformations, but if you want to draw the graph of this equation, first you need to identify the parent equation and then do transformations according to this order here. So the parent function is y equals x to the power 2 function. You can see that in here. So now with this parent function, the first thing is to do is this horizontal transformation. Here you can see that we have a horizontal transformation which is with this k here, which is h here, which is 3 units. So the first horizontal transformation is y equals x minus 3 to the power 2. So this is the horizontal transformation. You can see that is x minus 3. So it is 3 units right hand side transformation. The second one is if you have reflections or stretching or shrinking ones. Here we have a reflection transformation because we are multiplying this original equation by minus sign here, and parent equation by minus sign, and we have a stretching one because we are multiplying it by 2. So then we do stretching and reflection transformations together here. The final one is we need to care about the vertical, that is plus 4 here. So we add plus 4, that means we should move this graph, the graph of this function, upward by 4 units. So that's how we do that. Again, we have one more topic to talk in this section. It's about symmetricity. We will talk about in next video, and I will be online today from 5 to 5:30, 5 to 5:50. If you have any questions, you can contact me, and also if you can contact me in my office hours, or you can email me anytime. Right. Have a nice day.